All right. Starting section 2 of chapter 3. We're going to learn two different things here. We're going to learn how to solve two equations with two unknowns, but we're going to be able to do it two different ways. First way is going to be through what's called substitution. The second way is going to be what's called elimination. All right? Chapter 2, section 3. First way we're going to learn to solve in two equations, two unknowns, is through substitution. And then the second way is going to be elimination. 19th. This is practice. Okay? Let me show you an example of what I'm talking about. All right? I'm going to use x plus y equals 5. And then I'm going to have another one, 2x plus y equals, say, 10. Okay? All right? Substitution means I'm going to take one of these equations, I'm going to solve for a letter, and then I'm going to plug that letter back into the other equation. So if I did that, probably the easiest one to solve for is this one up here, x plus y. Right? Let's solve it for x. Let's say x equals something. So we would bring the y to the other side, and we could say x equals 5 minus y. All right? All right, the next thing we do is we take this, we solve for x on this equation. Now we're going to take this x and we're going to plug it in for the x right there. How do I get x like this? I subtracted y from both sides. Okay? So I can come up with 2 times 5 minus y plus y equals 10. And solve. 10 minus 10y plus y, I'm sorry, 2y. It's 2y, Fletcher. Equals 10. And now I can start solving for this. A negative y equals 0, y equals 0. If I plug this back up into my original equation, I can plug it actually right into there, x equals 5. So my two values here are x equals 5 and y equals 0. This is called substitution. Well, that's why it's called substitution. All right? This is one equation. This is two equations. You've got two equations, two unknowns. All right? So what I did is I solved for this first equation. I solved for x in this first equation. I just brought y to the other side, so it's 5 minus y. Okay? Okay. No idea. You got it, Fletcher? Got her? All right. So let's try one more through substitution. I'm going to take this top one. And it's actually pretty easy. They use y equals x plus 1, and they use 2x plus y equals 7. Well, they already have one of them solved for you, right? Y equals x plus 1. All we have to do is plug this here in for the y, right there. So we can say 2x plus x plus 1 equals 7. 2x plus x plus 1 equals 7. We solve this, 3x equals 6, x equals 2. Do you see where I went from here to here? I brought my 1 over and I added up my x, right? So if x equals 2, I can plug that back into this equation right up here to figure out what y is. What's y going to equal, Reese? Y equals 3. Yep, 3x equals 6. So we have our answers. X equals 2, y equals 3. That's substitution. Okay? Pretty easy. See what we got to do on that? Elimination. X plus y equals 10, and x minus y equals 2. Elimination means we're going to eliminate one of the variables. We're going to either add or subtract the equations to be able to eliminate one of the variables. So this is all you do. Draw a line underneath it, all right, and take a look and say, can I add or subtract variables to get rid of them? I can subtract the x's, right? Okay. So we can do it this way. Subtract x from x, and this becomes 0. Minus becomes a plus, so this becomes 2y, plus 2y, and this equals 12. No, well, it just shows. I'm just showing that. You don't have to. You really end up with 2y equals 12, right? Y equals 6. Is there another way we could have done this? Well, yeah. Let's take a look at this. What if we would have added? What if we would have added those two together? X plus x is 2x. This was a minus y here, right? Plus y minus y is 0, so we can just leave that out. Equals what? 12. I subtracted when I added when I should have subtracted, right? Yeah, and I was wrong before. X equals 6, and we can put that in there. Actually, y equals 4. If I would have done this right, I added these two together, and I should have subtracted them. Yeah. So, yeah, correct that on your page. Yeah, I would have 8x, y equals 4. All right? That's called elimination. Let's take a look at another one, though, that isn't going to be as easy. X plus 2y equals 10, and 3x minus y equals 9. Is there anything we can add or subtract to be able to get rid of one of the variables? Really, we can't, can we? So here's what we have to do. We have to equate these somehow. We have to equate these somehow. We got to either get rid of the x's by multiplying each one of these by 3. Nikki, what would I do here? Pay attention. I got 3x here. I'd have to multiply each one of these by 3 to get it. Fletcher, what would I do here? What would I do then? Which one? 2y and what? 2y and 3. I'd multiply them by 3. Okay, pay attention to what I'm doing here. Obviously not, because you didn't get it. I'd multiply the top by 3. Fletcher. I'd multiply the top by 3, and then I'd make both of these 3x, right? And then I could subtract them. Or I can multiply the bottom by 2, and then I'd have a plus 2y and a negative 2y. I can do it either way, all right, to get it. So what I'm going to do here is I'm going to turn around and I'm going to multiply this bottom one by 2, just because I love to add. So I'm going to write down my top one again. And I multiply the bottom one by 2. 6x minus 2y equals 18. So if you notice, all I did is I just recopied this one down, and then I multiplied this bottom one right here by 2. Okay? Now I have variables that are alike. Now I can just add these and I can eliminate my y's. So I get 7x, 2y minus 2y is 0, equals 28. X equals 4. See what I did to get rid of those? Okay? And if x equals 4, I could take this and I could plop this back in either one of these to be able to figure it out. And I could say 4 plus 2y equals 10, 2y equals 6, y equals 3. To be able to figure out what my y is. So now I'd have my y equal 3 and my x equal 4. Okay? See what I did up there, Fletcher? I took my x, put it in there. Okay. See what I did, Preston? Look pretty easy? Okay. This is called substitution and elimination. All right? Substitution and elimination. That is what you're going to do on your assignment. Any questions on this? Should I do any other examples? What happens if I have something like this? 2x plus 5y equals 20. 3x plus 3y equals 12. What would I get? That didn't. I didn't eliminate one of the variables. How you do? That's called elimination. You eliminate one of the variables. You could make these both 15, or you can make these both 6. Right? So then I'd multiply this one times 3 all the way through, and I multiply this one by 2. So then I'd end up with 6x plus 15 equals 60. And the bottom one would be 6x plus 6. Oh, this is a y here. Y equals 24. Now I could subtract them, right? So I'd end up with 9y, and this would be 36 equals 36. Y equals 4. I could plug that back in and figure it out. You can multiply through, as long as you do each term in the equation, you can multiply both the top and the bottom. Yes, Preston? 3 times 20. I went 3 times 2, 3 times 5y, and then 3 times 20. Okay? What do you mean? Either way, if you can do it substitution, if it's easier to do substitution, do it substitution. But what's going to happen on the assignment, they're going to say do these by elimination, and then they're going to say do these by substitution. But if you're trying to figure it out, 2 variables, 2 unknowns, at whichever one would work best. But on the assessment, I'm probably going to tell you I want this one figured out by substitution. I want this one figured out by elimination. All right? Take a look at 3-2-1 assessments. You got 3 problems. They say do it by 4 problems. Do it by substitution. Looks pretty easy, doesn't it? Look at that. They give you one of them there. It's pretty easy. Let's take a look at 2. And do those by elimination. Don't worry about number 9. 1 through 8.